enjoy learning!
Hello everyone! Welcome to Week 8 lessons in General Mathematics. I am Sir Jason Reyes, your Mathematics 11 teacher, and I will discuss to you the truth values of propositions and logical equivalence and conditional propositions. Sit back, relax, and enjoy learning! For our first lesson in General Mathematics, we will discuss about the truth values of proposition. The most essential learning competency. At the end of the lesson, you are expected to determine the truth values of propositions. Truth values. Truth values refers to the truthfulness of proposition that may either be true or false. Meaning to say, we are finding the truthfulness of a proposition that may either be true or false. Like in our relationship, we are always finding our true love. Love can either be true or false. So, as an individual, we should always find the truth values. Have you ever find your truth values? Truth table. Truth table is the table that shows the complete possible truth values of a proposition. So, basically, the use of truth table is to identify the possible truth values in every logical operator. So, we have 4 basic logical operators, and each logical operator has its own truth table. Upon using the truth table, we can determine the truth values. And the truth values can be categorized into 2, the tautology and the fallacy or contradiction. Tautology is a compound proposition that always produces true truth value, while fallacy or contradiction is a compound proposition that always produces a false truth value. So, meaning to say they are opposite to each other. Tautology, true truth value. Fallacy or contradiction, false truth value. A proposition P has the following truth table. Proposition P, true, false. Suppose we are given 2 propositions P and Q, therefore, we have 4 possible combinations of truth values. So as you can see, this is the standard truth table for proposition P and proposition Q. For proposition P, it is true, true, false, false. And for proposition Q, it is true, false, true, false. So, let us remember that it is standard and we will use it all throughout our discussion. So, please remember this truth table. In finding the truth values of proposition, we should know first the 4 logical operators. So, basically, we have 4 logical operators, which are conjunction, disjunction, conditional, and biconditional. So, conjunction, we have the logical connector and. For the disjunction, we have logical connector or. And for conditional, we have logical connector if, then. And for biconditional, we have if and only if. We should also familiarize the logical operator symbols. So, below is the symbol for each proposition. Conjunction, inverted V. Disjunction, V. Conditional, arrow to the right. Biconditional, arrow left and right. Last week, I already introduced to you the truth table for conjunction. At ito ang truth value for conjunction. However, in this week, I will elaborate more to you how to find the truth table for each logical operator. So, dati, memorize natin yung table. Pag sinabi conjunction, true, false, false, false. Ngayon, I will explain to you how we arrive at each truth value. So, paano kung walang table? Paano natin sasagutin? Dapat, we understand it. We just not memorize the truth table, but also we understand how we get the truth value of each proposition. So, ganito, paano? So, we have to understand the rules. So, we have rules. In conjunction, if both P and Q are true, then the truth value of the compound statement is true. So, sabi, kapag nakakita ka daw ng dalawang true sa proposition P and Q, automatic, true yon. So, ito yon. True, true. So, meaning to say it's true. Next. If there is false, then the truth value is false. So, the second rule states that if you found any value of false in any P and Q, then automatic the P and Q is false. So, let's see. True, false. So, on this, we have false. So, automatic, it is false. Next. False, true. So, we have false. So, the result is false. False, false, automatic, it's false. So, it is easy to determine the truth table for conjunction. So, it is true, false, false, false. Okay, let's move on to the truth table for disjunction. Last week, I had already introduced to you this table. Pero sabi ko nga sa inyo, pinakita ko lamang. Hindi nyo alam kung paano kinuha. Minemorize nyo lang. Ang gusto ni Sir ay hindi nyo lang i-memorize, kundi maintindihan nyo kung paano ito nakuha. So, we have also rule to follow in finding the truth table for disjunction. So, ito yon. In disjunction, if any of the propositions is true, or if they are both true, then the truth value for the compound proposition is true. So, napakadali lamang na rule. Padaliin natin. So, ito lamang yan. Ang rule dyan is, bigyan mo lamang ako ng isang katotohanan or true, and the value of the P or Q will be true. So, paano yun? Let's have the table. True, true. So, di ba? We have true. Dalawa pa nga. So, the value of the P or Q is true. Next. True, false. So, in this, we have the value of P which is true. So, sabi nga natin, bigyan mo lamang ako ng isang true, magiging true. False, true. Meron ulit tayong true. So, basically, the result is true. And the fourth, false, false. The answer is false. So, the truth table for disjunction is true, 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 false. Let's move on to the truth table for conditional. So, this is the truth table for conditional which I have presented to you last week. Sabi ko nga sa inyo, minemorize nyo lang yon. Pero for this week, aalamin natin how we come up with these truth values. So, gaya nung conjunction at disjunction natin, we have rules to follow. Ito yung mga rules. If both P and Q are true, or if both propositions are false, then the truth value is true. So, meaning to say, we will find out the value of the proposition P and Q are both true or false. So, punta tayo dun sa truth table. So, true, true, it is true. Then, if P and Q are not the same, the truth value will be determined by focusing on the second statement or the conclusion. So, sa truth table natin ng conditional, P is the hypothesis and Q is the conclusion. So, anong sabi? Kapag daw magkaiba yung P and Q, we will focus on the conclusion part. Dito lamang tayo titingin sa Q. Hindi tayo titingin dun sa P. We will see it on the second statement. Okay. True, false. So, criteria magkaiba. True, false. So, apply. Tumingin daw tayo doon sa second statement or the conclusion. So, meaning to say, if it is true, false, then P implies Q is false. Then, false, true, magkaiba uli. Titingin tayo dito sa conclusion part. So, false, true is true. Next, false, false. So, balik tayo dun sa rule na una. Both proposition are false. So, false, false, true. So, meaning to say, the truth table for conditional is P implies Q is true, false, true, true. Truth table for biconditional. So, as you can see, this is our truth table for biconditional, which is nakita nyo na last week, pero minemorize nyo lang. So, for this week, we will find out how we'll come up with these truth values. So, like in our conjunction, disjunction, and conditional, we had rules to follow. So, these are the rules to follow in finding the truth table for biconditional. If both P and Q are true, or if both propositions are false, then the truth value is true. So, paano yun? So, we will look on the P and Q, and the rule states that if magkapareho na true at magkapareho na false, the result is true. So, tingnan natin. True, true. So, meaning to say it is true. Next, if P and Q are not the same, the truth value is false. So, unlike sa conditional, natitingin tayo sa conclusion, on biconditional, if one of the P and Q is false, automatic, false ang sagot. Wala na tayong pag-iisipan. False na agad yun. So, tingnan na natin. True, false. So, criteria, P and Q, true, false. Meron tayong nakitang false. So, automatic, false. False, true. Meron tayong false. Automatic it is false. Then, false, false. Balik tayo sa criteria 1. If both P and Q are false, then the truth value is true. So, false and false is true. So, meaning to say, the truth table for biconditional, P, if and only if Q is true, false, false, and true. Please refer to the summarized truth table of logical operators. P, true, true, false, false. Q, true, false, true, false. P and Q, true, false, false, false. P or Q, true, 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 false. P implies Q, true, false, true, true. And P if and only if Q, true, false, false, true. This truth table is very important in solving the truth values of propositions. Knowing the truth table of each logical operators, we will now use it in determining the truth value of each proposition. Illustrative example number 1. Let P and Q be propositions. Determine the truth value of each proposition. So, P implies P or Q. So, as you can see, this is a compound proposition. So, how will we solve the truth value of this proposition? So, the first step is to determine how many tables do we need to solve in order to find the truth value. So, we need the value of P, the value of Q, the value of P or Q, and the value of P implies P or Q. So as you can see, we have 4 tables. So P, Q, P or Q, P implies P or Q. And on our previous slides, we already have the value of the P, the Q, and the P or Q. So it's automatic. For proposition P, it's true, true, false, false. For proposition Q, it's true, false, true, false. And this column, P or Q, is a disjunction. So based on our previous slide, the truth value for disjunction or P or Q is true, 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 false. So we have the value of P, Q, and P or Q. So the only thing that we need to solve is the P implies P or Q. So how will we solve this proposition? We need the value of P, which is this, and the value of P or Q, which is D. And look at this. This is a conditional proposition. So applying the rule, so P, true implies true, it is true. True implies true, it is true. False implies true, it's true. F implies F, it's true. So we can see that P implies P or Q is true. So therefore, this proposition is a tautology. Steps in finding truth values of proposition. So in finding the truth values of proposition, we have 3 steps. Step 1, analyze the entire compound proposition. So in analyzing the compound proposition, we should know how many logical operators are present on the proposition. So this is important because it will determine how many columns do we need in the truth table. So after that, step 2, construct the truth table of the proposition. So after knowing the logical operators, we will now determine the truth table. So how will we determine it? So we will just apply our knowledge of knowing the truth tables that we use on the previous slides. In step 3, determine the truth value using the truth table. So we will now look at the result of the truth table. So if the truth table shows a all true value, then it is a tautology. And if it shows a false value, it is a fallacy. To fully understand the truth value of the proposition, let's have another example. Illustrative example number 2. Let P and Q be propositions. Determine the truth value of P and negation of Q and P and Q. So what will be our first step? So our first step is to determine the number of truth tables do we need to find to simplify the compound proposition. So in this proposition, we need the value of P, the value of Q, the value of negation of Q, the value of P and negation of Q, the value of P and Q, and the value of the entire proposition, which is P and negation of Q and P and Q. So basically, this is the truth table. So P and Q are constant. For P, it's true, true, false, false. For Q, it's true, false, true, false. So the third column is the negation of Q. So all we need to do is to negate this Q. So how will we do this? So So the negation of true is false. Negation of false is true. Negation of true is false. And negation of false is true. So after finding its negation, we will use the negation to find the value of this. P and negation of Q. So we will compare these columns. The P and the negation of Q using the conjunction. So this is a conjunction. So as per conjunction, makakita ka lamang ng isang false, magiging false na. So true, false, magiging false. True, true, it's true. False, false, it's false. False, true, it's false. So after that, we already have the value of P and negation of Q. So we have this term. So we will now find the value of the P and Q. So P and Q is our conjunction. We already had this value. And on our previous slide, we consider that the P and Q is true, false, false, false. So it is the same as our truth table on the previous slide. Then we have the value of this proposition and the value of this proposition. So we apply again the conjunction. So false, true. Sabi ko nga sa inyo, pag may false, it automatic false in conjunction. So it is false. True, false. Meron ulit tayong false. It will be false. False, false. It will be false. False, false. It is false. So after that, look at the value of the final proposition, and it clearly states that the entire proposition is a fallacy because all of the proposition is false. False, 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 false. Illustrative example number 3. Let P and Q be propositions. Determine the truth value of P implies Q implies negation of P or Q. So what will be our first step? So our first step is to determine the number of truth tables that we need in solving the entire proposition. So let's identify. So we need the value of P, the value of Q, the value of P implies Q, the value of negation of P, the value of negation of P or Q, and the value of the entire proposition, which is P implies Q implies negation of P or Q. So as you can see, P and Q are constant. Ginamit na natin ito on our previous slides. Hindi ito magbabago. So for P, it's true, true, false, false. For Q, it's true, false, true, false. On the third column, it is a conditional. So on our previous slide, we already have the value of the truth table for P implies Q. So it is true, false, true, true. So we already have the value of the P implies Q, which is true, false, true, true. The next step is to find the negation of P. So we will just negate this proposition P. So negation of true is false. Negation of true is false. Negation of false is true. Negation of false is true. So after that, we need to find the negation of P or Q. So we will compare this negation of P and Q. So on our disjunction, sabi nga natin, bigyan mo lamang ako ng isang katotohanan. and the entire proposition will be true. So let's compare. False, true. So it will be true. False, false. It's false kasi wala tayong true. True, true, and it will be true. True, false, and it is true. So we already have the value of P implies Q and negation of P or Q. So ito na yung dalawa natin kailangan para masagot yung entire proposition. And it is a conditional. So sabi natin sa conditional, kapag true or false ang both proposition and it is true. Okay, let's check. P implies Q, ito yung unang kailangan natin, and negation of P or Q. Let's try. True, true. So both true. It is true. False, false. It's true. True, true. It's true. And true, true. It's true. So the proposition is a tautology because our truth value is true, 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 true. We will now proceed to the lesson 2 of our week 8 in general mathematics, which is all about logical equivalence and conditional propositions. Most essential learning competency. At the end of the lesson, you are expected to illustrate the different forms of conditional propositions. Logical equivalence. The propositions P and Q are said to be logically equivalent if they have the same values in the truth table and if the biconditional is a tautology. So meaning to say, it can be called logical equivalence if it satisfies two conditions. One, it has the same values in the truth table, and two, if the biconditional is a tautology. It is denoted by this symbol. So you can use this symbol or this symbol. Here are some of the table of logical equivalences. Let P, Q, and R be propositions. So we have the basic laws like identity law, domination law, idempotent law, inverse law, double negation law, associative law, commutative law, distributive law, De Morgan's law, absorption law, and Switchero law. Illustrative example. Using logical equivalences, verify that negation of P implies Q is logically equivalent to P and negation of Q. So upon using such law, it is proven that these two propositions are logically equivalent. So given negation of P implies Q, then it is logically equivalent to negation of P or Q, which is Switchero law, logically equivalent to negation of P and negation of Q, De Morgan's law, logically equivalent to P and negation of Q, double negation law. So all of those identities are already proven that they are logically equivalent. So if you need or you want to prove that they are logically equivalent, we can also use our truth table and it will yield the same truth value, whether it is a tautology or a fallacy. Conditional statement. A conditional statement symbolized by P implies Q is an if-then statement in which P is a hypothesis or cause and Q is a conclusion or effect. Meaning to say, conditional statement is composed of two parts, namely the hypothesis or cause and the conclusion and effect. Conditional statement can also be translated in three other conditional statements, namely converse statement, inverse statement, and contrapositive statement. To form the converse of conditional statement, interchange the hypothesis and the conclusion. On the other hand, inverse statement can be formed by negating the hypothesis and the conclusion of the conditional statement. Lastly, contrapositive statement can be formed by negating the converse statement. So on the next slide, I will show you the logical symbol used on converting conditional statement to three other conditional statements. To fully understand translating conditional statements to other form of conditional statements, let's have some examples. Example number 1. Filipinos are God-fearing people. I truly believe that Filipinos are God-fearing people. Why? Because Filipinos always put God at the center of their life. So how can we convert this conditional statement to other forms of conditional statement? Okay, let's look at the table. So this is the original conditional statement. If you are a Filipino, then you are God-fearing people. So first step is to identify the hypothesis and the conclusion part. So in this statement, if you are a Filipino is the hypothesis and you are God-fearing people is the conclusion. To form the inverse statement, we simply negate the hypothesis and the conclusion part. So how? By simply putting the word not on the hypothesis and the conclusion part. So the inverse statement is, if you are not Filipino, then you are not God-fearing people. Next, converse statement. So converse statement is formed by simply interchanging the hypothesis and the conclusion part of the conditional statement. So the hypothesis became conclusion and the conclusion became hypothesis. Okay? So the converse statement is, if you are God-fearing people, then you are a Filipino. As you can see, this is a hypothesis and from the conditional statement, it is a conclusion. And this is a conclusion while on the conditional statement, it is a hypothesis. We simply interchange. While contrapositive statement can be formed by just negating the converse statement. How? By putting the word not on both the hypothesis and the conclusion. So the contrapositive statement is, if you are not God-fearing people, then you are not Filipino. Okay, let's have another example of translating conditional statements to other forms of conditional statements. Example number 2. Good citizen obeys rules and regulation. So it is important for us to obey rules and regulation. So we must be a law-abiding citizen. So how can we convert this conditional statement to other forms of statement? Okay, let's look at the table. Conditional. If Paulo is a good citizen, then he obeys rules and regulation. To form the inverse, we simply negate the hypothesis and conclusion of the conditional statement. So how? By just simply putting the word not on the hypothesis and the conclusion part. So the inverse statement is, if Paulo is not a good citizen, then he does not obey rules and regulations. Next, converse statement. So how can we form the converse statement? We simply interchange the hypothesis and the conclusion part of the conditional statement. Okay, let's interchange. If Paulo obeys rules and regulations, then he is a good citizen. So we simply interchange the hypothesis and the conclusion part of the conditional statement. Lastly, contrapositive statement. So to form the contrapositive statement, we simply negate the converse statement. We will negate this statement. So how? We simply put the negation word not on the hypothesis and the conclusion. So what is the contrapositive statement? If Paulo does not obey rules and regulations, then he is not a good citizen. Example number 3. Following health protocols will prevent COVID-19. It is truly important to follow health protocols issued by IATF to prevent COVID-19. We should ensure safety of all by observing social distancing and proper hygiene. So how can we convert this conditional statement into other forms of conditional statement? Okay, look at the table. Conditional statement. If you follow the health protocols, then you prevent COVID-19. So our first step is to identify what is the hypothesis and what is the conclusion. So in this statement, the hypothesis part is if you follow the health protocols, and the conclusion part is you prevent COVID-19. To form the inverse statement, we simply negate the hypothesis and the conclusion. So how? We just put the word not on the hypothesis and on the conclusion. So in the inverse statement is, if you did not follow the health protocols, then you did not prevent COVID-19. Next, converse statement. So converse statement is formed by interchanging the hypothesis and the conclusion part of the conditional statement. Okay, let's interchange. If you prevent COVID-19, then you follow the health protocol. So in this statement, we already interchange the hypothesis and the conclusion part of the conditional statement. Lastly, to form the contrapositive statement, we just negate the converse statement. So we will look at the converse statement and put the negation part. So how? We just put the word not on the hypothesis and the conclusion part. So this is the negation, not in the hypothesis and not on the conclusion. So what is the contrapositive statement? If you did not prevent COVID-19, then you did not follow the health protocols.